moment diagram. We'll be looking at the shear force and bending moment diagram. In our last class, when we did the introduction to shear force and bending moment diagram, we've seen the concept behind being load support, right? And we've seen how load works, the conversion of load, you've seen that. So that's what we'll be implementing here. But before then, by definition, let's take down what shear force means and what bending moment means. Now, by definition, take down shear force. By definition, shear force simply means the algebraic sum of forces. Shear force simply means the algebraic sum of forces at any section of the beam. Either to the left or to the right. Shear force simply means the algebraic sum of forces at any section of the beam, either to the right or to the left. Next up, bending moment. What is bending moment? By definition, bending moment simply means the algebraic sum of moment. At any section of the beam, either to the left or to the right. Are we together?
Yes, sir.
Alright, if you look at that definition, you can see that both shear force and bending moment, they are synonymous, right? The difference is that when it comes to shear force, we are analyzing the forces, the vertical forces. When it comes to bending moment, we are analyzing, or we are referring to the vertical forces and the perpendicular distance. Alright, the very first example that we are going to be looking at is the simplest among all examples of shear force and bending moment diagram. So this is, you can draw this diagram. We have this. Question says that, let's say, imagine you are given this question, you saw this question in your exam. The question says that, draw the shear force and the bending moment diagram. Draw the what? Shear force and the bending moment diagram. Now, let me tell you one secret about shear force and bending moment diagram. Whatever principle that you know, if you can, given a question, and you are able to solve that beam yourself, like from step 1 up to the last step, successfully, you draw the shear force diagram correctly and you draw the bending moment diagram correctly. The secret is that the same way you analyze that particular beam, it remains the same for any type of beam. So what I'm trying to say in essence is that the principle remains the same. It's just you doing repetition. Are you getting me? Now, for this particular question, identify what type of beam is this. This is a simply supported beam, right? Now, this simply supported beam, what type of support is it having? You know, we've seen the concept behind support. We said we have roller support, pin support, and a fixed support. And they also say that we have statically determinate beam and statically indeterminate beam. Now, for your level, or what will be seen given any question as far as strength of material is concerned, our beam, it can only have two types of support, which are the roller support and the pin support. In advanced level, you can see fixed support. Are you getting me? Now, this support is there just to like test your ability or your intelligence on what support means. Meaning, do you truly understand what support means? Are you getting me at all? Now, we said each support has their respective reaction, right? Each support has their respective reaction. Now, identify how many points do you have on this beam? How many points? 3 points. Now, at what point do you have your support? A and B. At point A, what type of support do I have at point A? Roller support. What type of support do I have at point B? Pin support. Is either you call it pin support or you call it hinge support. Now the question is that what's the reaction for pin support? Yeah, what's the reaction for pin support? Pin support. This is your pin support. What's the reaction? Horizontal and vertical, right? Meaning you have what? Ry and you have Rx. What's the reaction for roller support? This guy. So what you are doing is that once you identify that this is a pin support and you have this reaction, this is a roller support and you have this what reaction, your next step, or you say your next task, is to substitute this reaction wherever you have the support. And this is what we call free body diagram. This is what we call what? Free body diagram. Now by definition, take down, what is free body diagram? What is free body diagram? Free body diagram is a diagram. Free body diagram is a diagram that shows the hidden force in a structural system. Free body diagram is a diagram that shows the hidden force in a structural system. That shows the hidden force in a structural system. Now that definition, I always love us to understand a particular definition. Are you getting me? Now that definition, do you understand what it means at all? You know, earlier, by the time you draw this beam, okay, let's do it this way. Okay, let's do this. Now, meaning your first step is to what? Draw the free body diagram. Your first step, draw the free body diagram. So let's do that together. You know how it works. Wherever I see this pin support, I'm substituting this, right? Wherever I see this, I'm substituting this. So let's do that. Meaning, I still have my beam repeated, but only my supports are changing. So this is 30 kilonewton. This is A, this is B. Right? Now, say this is case 1. Say this is case 1 and call this case 2. Call this case 1, call this case 2. Now, my question for you guys is that between case 1 and case 2, what can you observe? What's the difference between case 1 and case 2 in terms of forces? Identify case 1. How many forces do we have? Identify case 2. How many forces do we have? When I say force, consider your load and your support as your forces. Consider your load and your support as your forces. So check that. How many forces do you have here? 3. How many forces do you have here? 4. Now go back to the definition of free body diagram. You know what? Structural. Meaning there's a hidden force in this structural system. But with free body diagram, this hidden force has been what? Shown. Are you getting it? So that's the concept when it comes to what? Free body diagram. Meaning, generally, as far as shear force and bending moment is concerned, your first task is what? Draw the free body diagram. But some question will come directly, meaning the question will not stress us. So you don't have to draw the free body diagram. Alright, having drawn your free body diagram, the next step is to consider the equation of equilibrium. Consider what? Equations of equilibrium. Now, what are these equations of equilibrium? They are just what? 3. They are just 3. The first one is what? Summation of f of x is equals to 0. Summation of f of y is equals to 0. And summation of moment about any point is equals to what? 0. Now, why are we implementing this equation of equilibrium? We want to calculate RAY, RBY, and RBX. Usually, you see a question like this. The question says that it will say that question 1A, determine the support reaction. Question 1A, determine the support reaction. Then 1B, draw the shear force and bending moment diagram. Meaning, you are going to determine, when we say support reaction, meaning RAY, RBY, and what RBX. I believe you've done this in applied mechanics, right? You've done this in applied mechanics. So let's see. Solution. Let's consider this first condition of equilibrium. You considering this first condition of equilibrium, what do you have? Summation f of x equals to what? 0. Now, when we say summation f of x equals to 0, you know, each equation, there has sign convention. I believe you know what it means by sign convention, meaning positive force and negative force. Now, when considering this particular equation, force of this nature, they are considered positive, right? Force of this nature, they are considered negative. Now, from your beam, how many force of this nature do you have? How many force of this nature do you have? Just one. Meaning that RBX is equals to what? 0. RBX is equals to what? 0. But in some cases, whereby you have an inclined force, whereby you have what? An inclined force, RBS won't give us 0. We have a value for RBS. Let's say, for instance, this 30 kilonewton, we have it inclined to the horizontal as this. Let's say this is 30 kilonewton and it is inclined to the horizontal axis 40 degree. You know, from here RBX is equals to 0, but in this case RBY can never give us 0. Do you know why? What's the reason? Because this inclined force, it is what? Horizontal and vertical. By the time you resolve it into the horizontal component, then you can equate it with this, right? So that's it. Now the next one is what? Summation of f of y. Summation f of y. When considering this equation of equilibrium, force of this nature, they are what? Positive. Force of this nature, they are what? Negative. They are negative. Meaning that first thing first, I want to consider this equation. Go back to your free body diagram. Identify how many type of forces do you have? How many force of this nature do you have? And how many force of this nature do you have? Right? Now, before I forget, look at this beam very well. From here, this is C. Call this C. This is point C. Depending on some lecturers, if they want to mark your script, they will consider a lot of things. Even though your calculations are so correct, perfectly correct, they will still want to deduct your mark, right? Just because they don't want to give you your full mark, let's say 50 over 50 or 30 over 30. So you need to watch out how you draw your diagram. You need to watch out how you draw your diagram. It is very, very important. You know, from A to C, I'm having what? 4.5 meter. From C to B, I'm having what? 5.5 meter. Meaning my 5.5 meter should be greater than what? 4.5 meter. Are you seeing that? So if you have your own diagram saying 4.5 meter and 5.5 meter, they are equal, it means from there you have a minus. So take note of that. It's very, very important, depending on the lecturer that wants to mark your script. Okay, now from here back to this equation. Summation f of y equals 0. Now identify how many force of this nature do you have? How many force of this nature? 2. They are what? Which are what? RAY and RBY. Meaning these two forces, they are considered positive, right? How many force of this nature do you have? Which is what? 30 kilonewton. That is 30 kilonewton is considered what? Negative. So let's write that. We have RAY plus RBY minus what? 30 minus 30 equals to 0. From here, 30 can go to the other side. We then have RAY plus what? RBY is equals to 30 kilonewton. Call this equation 1. Call this equation 1. Next up, let's consider this equation. This equation of equilibrium. And the third equation of equilibrium says what? Summation of moment about Alright, I love an interactive class. Alright, so now this last equation, it says what? Summation of movement about any point equals to 0. Keyword, any point. Now, earlier we've identified how many points do I have here? 3. I'm having 3. So when you are saying summation of movement about any point equals to 0, does that mean that we can take movement about A, we can take movement about B, we can take movement about C? Alright. Okay, we can take movement about C. You are wrong. You are wrong. You are wrong. So now, pay maximum attention. When taking your movement, always take movement. Always take movement where you have your support reaction. Always take movement where you have your support reaction. Always take movement where you have your support reaction. The idea is that when you are taking movement at the point where you have your support reaction, you want to eliminate that force. Are you getting me? You know, okay, are we done writing? Alright, let's take it back to mathematics. You know, in mathematics, hello, one else please. You know, in mathematics, let's say you have a simultaneous equation. Is it possible for us to get the two value of unknowns at once? No. It is not possible. I have to know one, then substitute it later to the other equation. So that's what we are trying to do here. Yeah. Now, you taking movement at wherever you have your support reaction, it means you want to eliminate the force that you have here. Meaning you eliminated it, just like the way we normally do in mathematics. So that's the concept. That is, you can either take movement at point A or point B. It's your choice. At the end, you get the same thing. It's your choice. You get the same thing. Any question on that? Now, with that being said, movement, you know, when we said this equation of equilibrium, when considering it, each of them, they have a sign convention. For the first one, this is the sign convention. For the second one, this is the sign convention. Now, what is the sign convention for this very guy? Which is what? Summation of movement about any point. Okay, now, what point should we take our movement to? At point A. At point A. Let's take movement about point A. Right, taking movement, this also attract mark, right? Whenever you want to take movement, write it. Taking movement about point A. This is like half mark on its own. So mathematically, you have this. Now, when taking movement, we consider the direction involved. We consider what? The direction. And we only have two directions, which are what? Clockwise direction and anti-clockwise direction. Clockwise direction and anti-clockwise direction. Now, for us to understand this very well, because I must be sincere with you guys. At this stage or at this point, if you don't understand how we take movement to get support reaction, you will find it very, very, very difficult. Emphasis on that. Very, very difficult when you want to solve bending moment diagram. So for easier calculation, or to make that easy for us, let's do a practical illustration, right? Now, we all have our work log at home, right? Now, our work log, I believe you know when it is clockwise and you know when it is anti-clockwise. When it is going in the normal direction, it is what? Clockwise. When you are going against the direction, it is what? Anti-clockwise. That is, when I have this direction, it becomes what? Clockwise. When I have this direction, what do I have? This say this is A and say this is B. This A, is it going in the direction of your clock or it is going against it? Let me ask that again. This A, is it going in the direction of your clock or it is going against the direction? It is going in the direction. Because A is going in the direction of your clock, it becomes what? Clockwise. Right? It becomes clockwise. What about this? B. Is B going in the direction or against it? Against it, meaning anti. What do you say? Meaning anti-clockwise. Anti-clockwise. Are we together? But to understand it better, okay, before then, this clockwise direction is actually in two forms. Are you getting me? It's actually in two forms. This anti-clockwise is also in two forms. Meaning, okay, to understand it better, let me just draw a wall clock visual. Let's say you have this. This is 12, right? 6, 3. What do we have here? 9. This is 1, 2, 4, 5, 7, 8, 10, 11. Now from here, let's do something like this. When you are going in this direction, hope you can see the board. When you are going in this direction, now from this wall clock, I want to indicate forward direction. Forward direction. And this forward direction, we are going to identify if it is clockwise or anti-clockwise. Now the first one, this direction. The second one, let's say you are going in this direction, you have this, and lastly you have this. Call this 1, call this 2, call this 3, and call this 4. Now, what direction is one going? Clockwise or anti-clockwise? Clockwise. What's your reason? What's the reason behind it going clockwise? What's your reason to that? Of our clock. Observe 9, 10, 11, 12. Meaning, whenever you have this direction, it becomes what? Clockwise. Right? Number 2, identify what direction? Anti-clockwise. Why is it anti-clockwise? It is going against the direction. 3, 2, and 1. Right? Number 3, identify 9, 8, 7, and 6. Anti-clockwise. Number 4, identify clockwise. 3, 4, 5, and 6. Right? I know why I'm emphasizing on this. I know why. Because this thing, it is the foundation of bending movement. It is the foundation of bending movement. If you don't know this, you can never get bending movement diagram. You can never get bending movement calculation that will give you the value. You know, it's just like you doing your physics practical. I believe everybody here will did physics practical in year 1. You know, when you want to draw your graph of let's say Ohm's law, V against R. Is it V against I? Then I get a linear line, which is R. Now, you know, before you can plot that R, before you can plot the resistance, you must know the value of the voltage and you must know the value of the current. Similarly, in mathematics too, you must know the value of the y-axis and the value of the what? X-axis. So meaning that if you don't know the value of bending moment and you don't know the value of shear force, how do you plot the graph? You can never plot the graph. You'll be plotting rubbish. You'll be plotting what? Rubbish. And to know this value, this is what you need. This is very, very, very important. So copy this down in your book or wherever, then you can reference it back later. Are we good to go? Alright, now let's take, he said taking moment about point A, right? We want to take moment about point A. By definition, what is movement? What is movement? By definition. Do you still remember what movement is by definition? What is movement? Perpendicular distance. All right. Movement simply means, or you say movement is the product of force times the what? Perpendicular distance. Now, I'm taking movement about point A. What did I say earlier? I said when it comes to movement, you can take movement either of the point you're having on your beam, right? Now, I'm taking movement at point A. Me taking movement at point A. What will happen to the force on point A? You are eliminating it, just like you are doing in mathematics, right? Now, you've eliminated the force at point A, what forces are you left with? How many forces are you left with? You know, we've gotten 0 for this, so this guy is not there again. We've gotten 0 for this. Now, how many forces are you left with? 2, which are what? 30 kilonewton and what? RBY. Now, by the definition of movement, force times what? Perpendicular distance. Meaning these two forces, they are traveling to A. This is the first one, 30. This is the force. The perpendicular distance. When you are saying perpendicular distance, meaning the distance this 30 is covering. Are you getting me? That's the first one. Number 2, RBY. What the distance this RBY is covering? That's what movement means. Now, let's just make it interactive now before we start solving. For this first one, I have what? The force here is what? 30 kilonewton. The distance is what? 4.5. Meaning I have 30 times what? 4.5, right? Let's keep that. The second one, what do I have? RBY. This is the force. The distance now is what? 10. How do you get 10? 5.5 plus what? 4.5. Now the question is, in what direction is this 30 going? Okay, this is wait. Let's do it this way. Let's do it this way. From here, the first one, I'm having what? 30 kilonewton, right? Let's say you have 30 kilonewton. 30 times what? 4.5. Right? The next one is what? RBY. Let's keep this. The next one is what? The next one is this guy, right? Meaning I have RBY times what? Times 10. This is what? 2, right? Now the question is, in what direction is this 30 going? And in what direction is this RBY going? Now come back to this. Check. This 30 kilonewton, in what direction is it going? What's the concept? Alright, now we said we want to consider this last equation. Alright, so what I was saying is that now we've considered this guy, right? We want to consider this very guy. Now, to consider this, we said movement. By the word movement, first time distance. I need a force and I need a what? Distance. Now, since we are taking movement about this point, it means RAY, we've eliminated it, right? You know, initially, I'm having 3 forces. But now, since I'm taking movement about this guy, meaning I only have 2 forces left. So my interest is these 2 forces. This being my interest. Okay, now imagine it this way. You want to tip the edge to point A, right? Also tip the edge to what? Point A. Now for this first one, tipping the edge to point A, you observe that it is covering a distance, right? And what's the distance? 4.5. So this is what you have here, 30 times 4.5. The second one also, RBY, tip the edge as well to point A. You also observe that it is covering a distance. The distance is what? The addition of 5.5 and what? 4.5, which is what? 10. And this is what you have here, right? You know, it is easy for me to identify, to know equation 1 and equation 2. But the technical part is that, is it going in a clockwise direction or anti-clockwise direction? Now, this will take us back to this analysis, or you say this analogy. Now, from here, with this, identify. This, let's say this is equation 1 and let's say this is equation 2. Equation 1, in what direction is it going? Is it clockwise or anti-clockwise? Clockwise. Why is it going in a clockwise direction? Okay, now this is it. You know, I have 1, 2, 3, 4. 1, 2, 3, 4. You are correct with your clockwise. But tell me, what part is it? among 1, 2, 3, 4? Is it 1? Is it 2? Is it 3? Is it 4? Look at it very well. It is what? It is 4. Yeah, it is 4. Now this is it. Let's say this is 30 kilonewton. Let's tip it in this way. Let's drag it like this. You are going like this. Meaning what? 4. That is clockwise, positive. So you have positive all into bracket. Let's do this together, please. 30. Are we tired? We've not started at all. Let's do it together. What do we have? 30 times 4.5. Then this, we did equation 2. Is it going to be positive or minus? Why is it negative? It is moving in an anti-clockwise direction. What part is it here? Is it 1? Is it 2? Is it 3? Is it 4? 2. It is 2. Meaning you have it in this manner. It is going like this to what? A. Right? Any question? Hope I'm communicating. Yes, sir. Alright, so you have it as what? Positive or negative? Negative. Meaning negative all into bracket. RBY times what? 10 equals to what? 0. Equals to 0. Alright, let's solve this. Let's simplify this. The product of this will give us what? I have 135 minus 10 RBY equals to what? 0. Now from here, what's that?
Based on this clockwise and anti-clockwise analysis, when we're doing stretch calculation, the lecturer assigned clockwise.
Okay. He assigned positive to anti-clockwise, negative to clockwise. That is correct. Do you know why it's correct? We can actually do that here too. It's just like you doing Kirchhoff's law. When you did Kirchhoff's law, we said that from positive to negative. You know, in my video, if you check the comment section, they are accusing me that when they check other videos or when they search online, they are saying me, I said, if you are going from positive to negative, you have it as positive, meaning voltage gain. If you are going, positive to negative, you have it as positive, meaning voltage gain. Negative to positive, you have it as minus, meaning voltage drop. But they are telling me the reverse. Both of us, we are still correct. We are correct just because by the time we stay consistent without very sign convention, it will still give the end product will still be the same. Something like that. But this is it. When you are consistent with a particular sign convention in whatever you are doing, the end product, like the result, will still be the same. Are you getting me? Now, from here, I'm saying that clockwise is positive, anti-clockwise is negative. If I remain consistent with that sign convention, my diagram, I will get the same thing with the person using it vice versa. Are you getting me at all? So what I'm trying to say is that whenever you are consistent with a particular sign convention, you definitely get the same thing. But in textbooks, for that man now, probably the textbook he's using, maybe that's what he saw there.
When you talk chemical, you give both. Because we also like statistic is not correct.
That's
the other one and the
same. Sure, you definitely get the same thing. That's what I'm saying. The textbooks will give you different approach. You get. Now let's resume. Let's back to what we are doing, please. From here up to this level, any question? I have 135 minus 10 RBY equals to what? 0, right? Now make RBY the subject of the formula. That becomes what? 10 RBY is equals to what? 135 kilonewton, right? From here, what's your next step from here? Divide both sides by 10, meaning that RBY, by the time you divide both sides by 10, what's the RBY? RBY is equals to 13.5 kilonewton. Call this equation 2. Now, we have two equations now. We have equation 1 and we have equation 2. Go back to equation 2. I have two unknowns, right? But out of these two unknowns, I've gotten RBY, which is my equation 2. To get the other unknowns, I can substitute equation 2 into equation 1. then I have what? RAY. So let's do that. From equation 1, I believe you've copied this down. This is what we'll be using in bending moment calculation. Very, very important. Alright, from equation 1. What's your equation 1? Recall. Right, recall. Recall from equation 1. What do I have from equation 1? RAY plus RBY is equals to what? Is equals to 0, right? This is my equation 1. 30 kilonewton, right? Now, let's substitute equation 2 into equation 1. It becomes what? RAY plus, hello, please, let's do this together. Plus what? 13.5 equals to what? 30. Therefore, RAY is equals to 30 minus 13.5. And this will give you what? Therefore, RAY is equals to 16.5 kilonewton. RBY, what's RBY? 13.5 kilonewton. What's RBX? 0. RBX is equals to what? 0. Now, I said, usually, how you are going to see your question in exam or in test, you'll be given a particular beam. Question 1A, it says that calculate the what? Support reaction. Calculate the support reaction. 1B will tell you that draw the shear force and bending moment diagram. Draw the shear force and bending moment diagram. Meaning that what we've been doing this morning is the first part. Of shear force and bending moment diagram, which are these values that we've calculated. So let's write this. I've answered question what? I've answered question 1. Question 1 should not be. Normally this diagram, I said when we started, I said this is the simplest diagram ever when it comes to shear force and bending moment diagram. This is the what? Simplest, right? So now, when I say simplest, it is very simple to the extent that you don't need to start solving, right, before you can draw the diagram. Meaning the mark that will be assigned to this is no more than 5 marks. It's no more than 5 or 2 marks. Let me check our own past question. If I'm not mistaken, probably it was 3 marks or 2 marks. Alright, let's continue. Now from here, we've calculated the support reaction. Support reactions, right? Which are what? RAY, RBY, and RBX. We've calculated the support reaction. Now, you will notice what I did here. In my next diagram, I'm using a board here. And even I was solving it, I'm going to, up to that level that we've calculated those values of RAY, RBY, and RBX, I'm going to draw another diagram. Are you getting me? I'm going to draw another diagram. So what that means is that up to that level whereby you've calculated or you've written the value for your support reaction, your next step is what? Draw another beam, draw the particular given beam, right? You drawing that beam, what you want to do is that you want to substitute the value that you've calculated for your the support reaction. Are you getting me? This was the given beam initially. Earlier when we drew this beam, I don't know this value yet, right? Now after solving, I substituted this value, meaning what's the value of RAY? 16.5 kilonewton. What's the value of RBY? 13.5 kilonewton. What's the value of RBX? 0. Now, when we did applied mechanism, I said this, in applied mechanism, you actually did this, right? But you guys stopped at support reaction. and you treated this under equilibrium of forces, right? Now, by the word equilibrium, what does the word equilibrium mean? Meaning something is static, meaning the net force acting upward is equals to the what? Net force acting downward. Now, what I want you guys to do for me is that I believe you can identify upward force and downward force. Now, sum these upward forces. Sum the upward force that you have here. It must give you the downward force. Are you getting me? Which is obvious. It's very obvious. By the time you sum this up, you'll be getting the downward force. You know, initially, say we've not calculated this. I just want to do an assumption, saying I have 20 kilonewton and I have 10 kilonewton. You know, I'm still correct, right? You know, I'm still correct.
Yeah.
That's because by the time I add these two values, I'll still be having 30. But these values, they are not the accurate value that this support reaction is supposed to be having. So this is where you take it to structure, meaning structurally. Are you getting what I'm saying? Now, when you have this type of structure, you know, this is a beam, right? When you have this type of structure and this load is subjected to it, and it is having 30 kilonewton, meaning RAY. Are we together? Or I'm too fast? I'm too fast. I'm fluid. If I'm too fast, you can bring me back. Alright. Now, for me, I said, I'm just, for the civil engineering students that are here, I'm just letting you guys to know. So now, from here, the main reason why we need to calculate is that, is to know, one house please. I said the main reason why we need to calculate is to know the precise force or the precise magnitude of your support. Alright, let's say I have this beam. Say you have this 30 kilonewton. This is A, this is B, this is 2.5 meter, this is 2.5 meter, this is C. RAY and RBY. You know, they are this beam that I have here and this one, you know, they are the same, right? They are the same. What is different? The difference is that the distance varies. This one I'm having equal distance, but this one, the distance, they are not equal. Now, the same, if you want to calculate the support reaction here, you know, it's the same process that we went through and solve for this one. That's the same process that I'm going to go through to solve for this, right? But I can just write my final value, which will be what? 15 kilonewton and what? 15 kilonewton. What's the idea behind this? And what's the idea behind this?
Because they equal distance.
They are symmetrical, yeah, that's the word. They are symmetrical. Because the distance is the same. That is, the beam, the load will be divided into two. It's just like your seesaw in what's it called? In primary school. So that's it. So meaning, as the distance varies, you have different value of support reaction. Now, let's start. The next one is what? Shear force diagram and bending moment diagram. I know that's what you all are waiting for.
Yes, ma'am.
Alright. Now, shear force diagram and bending moment diagram. Shear force and bending moment. Alright, now the next step is what? Or the next aspect is what? Shear force and bending moment diagram. That one was just support reaction. Alright, now from here, shear force and bending moment diagram. This is the main work. Please pay attention. Now from here, I said it and I will still repeat myself. I said, when you want to draw shear force diagram and bending moment diagram, it's just like you drawing. It's just like you doing mathematics or you doing physics. You have this value that you calculated from your experiment or from theory, and you want to plot this value on a graph sheet. That's what we are doing here. You want to plot this value on a what? Graph sheet. Now, what that means is that if I want to draw shear force diagram, I must have shear force value, right? I want to draw shear force diagram, I must have shear force values. I want to draw bending moment diagram, I must have bending moment values. Now, when calculating these values for shear force, there are some certain conditions that must be met or that you must put into consideration. Now, right, when calculating shear force value is calculated, okay? When calculating shear force, or first of all, right, when calculating shear force and bending moment, let me put it this way. Shear force and bending moment is calculated at each point on your beam. Shear force and bending moment is calculated at each point on your beam. Shear force and bending moment is calculated at each point on your beam. Now, check this beam. How many points do I have? 3. Meaning that at each point, there's a value for shear force, right? Meaning that at each point, there's a value for bending moment. Alright, now, take down also. Under shear force calculation, right? Shear force calculation. Number 1, when calculating shear force must, okay, number 1, shear force is calculated twice. When calculating shear force is calculated twice. Shear force is calculated twice. When calculating shear force is calculated twice. The first calculation, you consider the force, the algebraic sum of forces. The algebraic sum of forces behind a particular point, you want to calculate the shear force value. Just put in your word. The algebraic sum of forces behind a particular point, you want to calculate shear force value, or you want to get shear force value. That's number 1. Number 2, are we there? The algebraic sum of forces. Number 2, the algebraic sum of forces. Or let's do it this way. What's your number 1?
The algebraic sum of forces behind
now, number 2 is the combination of your number 1 and the forces on that point. Number 2, you've written number 1 down, right? Now, write number 2. Your number 1 plus the force on that point. Your number 1 plus the force on that point will give you the second value of shear force. I said number 1, when calculating shear force value, you calculate shear force value twice. How do you get the first value? The algebraic sum of forces behind the force you want to calculate. The algebraic sum of forces behind a particular point you want to calculate shear force value. We said shear force is calculated at each point on our beam. Let's say I want to calculate shear force value at point C, meaning that, okay, let's say I want to calculate shear force value at point B, meaning I'm considering the algebraic sum of forces behind this point B, right? That's your number 1. Your number 2 is now the addition of your number 1 and the force on the point, on that point. But you see what it means when we start solving. So we have 2 methods in which we can calculate shear force. But the one that is easier, or the easier one, is this one that we are about to do. If time permits, I will show you guys the other one. How it works for the other one is that you are going to section your beam at each point. But probably you see how that one also works, right? Then that's number 1 when calculating shear force. Number 2, shear force value must end with 0. Shear force value must end with 0. Number 2, shear force value must end with 0. As far as this level is concerned, shear force value must end with 0. In some cases, shear force value, it is not necessarily it end with 0, but as far as this level is concerned, shear force value must end with 0, right? And you can just take note.
What if you that?
Yeah, it's still correct. If you have 0.2, it's still 0. It's still correct. If you have negative 0.2, it's still 0. It's still 0. Now, you can take note. The reason why I said that is that, listen guys, the reason why I said that is that, you know, the type of support you'll be seeing in your beam is either you see pin support or you see what? Roller support. When you have these two type of support in your beam, meaning shear force will end with 0. It must end with 0. But if you're having a fixed support, shear force can never end with 0. If you're having what? A fixed support, shear force can never what? End with 0. If you have a fixed support, shear force can never end with 0. So that's the concept behind it, that we say that shear force must end with 0. So that's what we need to know under shear force. Now, bending moment, right? Bending moment must start with 0. Bending moment must start with 0 and end with 0. Bending moment must start with 0 and end with 0. Now, shear force calculation. All right, shear force calculation. By definition, shear force is defined as what?
You're giving some of vertical forces out of the different forces without the left or the line.
All right, by definition, shear force is defined as what?
You're giving some of vertical.
The algebraic sum of vertical forces at any section. Okay, the algebraic sum of vertical forces acting on the beam at any section, either to the right or to the left. What that means is that you can take shear force, either you take it to the right or you take it to the what? Left. What do you say? Okay, I'll show you. I said the algebraic sum of vertical forces, either to the right or to the left. Either to the right or to the left. Either to the right or to the left. Yeah. Yeah, you cannot have horizontal forces. That's true. You know, in this case, I'm having, that's a good question. I'm having RBS equals to 0. Let's say that I have RBS is equals to 14 kilonewton at point B, and I'm having RBC, meaning, I believe you know why this is RBX.
Yes.
Because the horizontal force is at B. So now, let's say I'm having RCX equals to 20 kilonewton, meaning that these two horizontal forces, can I use this, you know, I'm using vertical forces to plot shear force diagram, right? Now, these two horizontal forces, can I use them to plot a diagram? Are you getting me? Can I use them to plot the diagram? And the answer is yes. The type of diagram, it is called Asier diagram. You know, if you do stresses and strain, you are going to tell you that an Asier load, right? It is an Asier load 30 kilonewton in bracket tensile. When we say Asier load, it can, when we say Asier load, meaning horizontal load, right? So meaning that when you have, if possible, you see it in textbooks, and the diagram is plotted using the horizontal values, it is called what? Asier diagram. It is called what? Asier diagram. but I don't think we need that. But you can just know in case if you are reading on your own and you see it. It is called SFD diagram. Alright, now from here, shear force calculation. Shear force what? Calculation. I said you calculate the value of shear force at what? Each point. How many points do I have here? What's the first point? This will be an interactive class now. What's the first point? A. So right at A. At A. What's the value of x at A? When I say x, meaning exactly 0. X. What's the value of x at C? 4.5. What's the value of x at B? 10 meter.
We are taking a reference point.
Exactly, from A. So now, what's the value of x? 0 meter. So right, at A, x equals to what? 0 meter. And we said you calculate the value of shear force twice, right? Now, what's the condition when calculating the first value of shear force? How do you go about it? Read what you have in your notes. Check what I gave you guys. The what? Check now, I've given it to you. Alright. For the last time, read what you have. The algebraic sum of forces behind a particular point you want to what? Now in this case, at what point do I want to get shear force? At point A. A particular point, meaning you can have any point, but in this case I'm on point A, right? At A. Now at A, what do you consider to get the first value of shear force at A? What are you going to consider? Behind the algebraic sum behind the forces, the algebraic sum of forces behind the point you want to get the value of shear force. I'm on point A. Behind A, do I have any force or can I see any force? No. Meaning the first value of shear force is 0, or you don't even write it. Are you getting me at all?
Yeah.
Are you getting the logic? It's just idea. I just need the idea. Now I'm on point A. Me being on point A, I know that I'll get to value of shear force. I will get to value of shear force. Also, take notes. It's very, very important, because by the time you start solving complicated beams, it's very, very important. Those two conditions only works if possible. It's not necessarily those two conditions are met or they are satisfied. If you have it, then fine. If you don't have it, then you are still okay with it. Are you getting me? Now, from here, I'm having point A. Me having point A, do I have any forces behind point A? No. Meaning that the first condition of shear force, it does not apply to point A. Are you getting me? Meaning the first condition of shear force does not apply to what? Point A. Any question on that? Now, let's say I'm on point B. What is the first condition of shear force? Point B. Now, behind point B, how many forces do I have? Which are what? RAY and what? 30 kilonewton. Meaning you are going to take the algebraic sum, right? By the time you take the algebraic sum, meaning 16.5 plus what? 30. And that will give you what?
Minus 30.
No. Yeah, that's correct. That's 16.5 minus 30. And that will give you what? Minus.
I have a question. How do you want to know behind?
Behind means back, like back.
I know that it's back. But if I see this B that is here, is it not back? The back is not like
No. This is. Yeah, that's what I said. Shear force is the algebraic sum of forces at any section of the beam, either to the right or to the left. What you are saying now is to the right. What we are saying now is to the left. Are you getting me? Are you getting me? In case of right, maybe probably you have an overhanging beam. It is possible you take it from right. But in most cases, if it is a simply supported beam, you always take it from the left. Are you getting me? If you have an overhanging beam, probably you might take it from the right. But if in most cases, if you have a simply supported beam, you always take it from the left. Better still, for better understanding, you can just reference this very guy as 0, right? You know, that's why I said at A, what's the value of x? 0 meter. At C, what's the value of x? 4.5. At B, what's the value of x? 10 meter. Now, when you're on a point and you want to get the value of shear force, you already know that you get 2 value of shear force. But these 2 value of shear force, you are going to get it if the condition for shear force calculation are met or is met. If it is not met, it means you can have those 2 values. It's not necessarily you have those 2 values at each point. You only have those 2 values if the condition of shear force are met. Now, we now say the first condition is that I'm on a point. I'm on point A, right? Me being on point A, the first condition is that I'm considering the forces behind point A. Me looking at this beam, do I have any forces behind point A? No forces, meaning the first condition of shear force is not met or is not applied to point A. Now, check number 2 condition. What's number 2 condition? The force on that point, right? And what's the force on that point in this case? RAY, meaning 16.5 kilonewton. So, as far as point A is concerned, shear force value, the first value of shear force is equal to what? 16.5 kilonewton. That's all. Now, at C, what's the value of x? 4.5 meter. At C, the value of x is what? 4.5 meter. Now, the first value of shear force. Read what you have when calculating shear force value. How do you get the first value? Alright, looking at this beam, what will be your first value at point C? 16.5. I'm on point C. Me being on point C, I'm only interested in the forces behind C, right? This is C, behind C, meaning at the back of C. I'm seeing the force on A, which is what? RAY. What's the magnitude of RAY? 16.5. Meaning at C, the first value of shear force is what? 16.5. 16.5 kilonewton. Check number 2. What do you have? I said number 2 value of shear force at a point is what? The combination, meaning the forces behind and the force on that point. Are you getting me? The forces behind and the force on that point. Now, I'm still on C, right? The forces behind, what's the value? 16.5. The force on C, what's the value? 30. So the algebraic sum will give you what? 16.5 minus 30. Don't forget your sign convention. Force of this nature, positive. Force of this nature, negative. Right? I'm going in this manner, meaning 16.5. I'm coming in this manner, meaning what? 30 kilonewton. So what do you have? You have 16.5 minus 30, and this will give you what? Minus 13.5 kilonewton. Now you are going to see if truly, you know, all right, now go back to shear force calculation. I said the number 2 fact about shear force calculation is what? Shear force must what? End with 0. Shear force must end with 0. Meaning that's an hint for us. When if I'm solving shear force calculation, let's say we are solving shear force calculation, and your shear force is not ending with 0, you need to check yourself. Meaning there's something wrong. Something is wrong. But if your shear force is 0, meaning that you are correct. Now we are going to see it here. If our shear force will end with 0 or not. Now from here, at B, same idea. At B, what's the value of x at B? 10 meter. The first value of shear force is what?
Minus 13.5.
Alright. Minus 13.5. Any question on minus 13.5?
No, sir.
You just, it follows a regular pattern.
Yes.
The first value here, the last value here will be the first value here. Are you getting me? The last value at point A will be the first value at point C. or let me put it this way, the last value for the previous point will be the first value for the next point. You know, the first point here is point A, and the last value, we got this, right? Now, the next point, which is C, is going to be the first value, right? Now, I'm on point B. If this is my point B, following that order, what will be the first value here? Minus 13.5. But you can come back to your beam and check that. If this is my B, the algebraic sum behind it, how many forces am I having? I'm having 2, which is what? 16.5 and 30. By the time you take the algebraic sum of this, you end up having what? Minus 13.5. So meaning I have 16.5 minus 30, which will give me what? Minus 13.5 kilonewton. How do you get a number 2 value of shear force?
Combining
The forces behind and the force on that point. You know, behind I got minus 13.5. On that point, I'm having what? 13.5. By the time you combine it, what's the answer? 0. And what do we say about shear force? Shear force must end with 0. Must end with 0. So you have negative 13.5 plus 13.5, which is equals to what? 0. So this is shear force calculation. This is shear force calculation. Now, bending moment calculation. Let's go to bending moment calculation. Bending moment. Hope I'm not too fast. Now, same idea. Bending moment calculation. You calculate bending moment at what? Each point. You calculate bending moment at each point. Now go back to bending moment calculation. What do you say about bending moment? I said bending moment must start with 0 and must what? End with 0. So meaning that at A, let's write at A, meaning x is equals to what? X is equals to 0 meter. Bending moment is equals to what? 0. What's the unit for bending moment? Kilonewton meter. Bending moment first time distance, right? Newton meter. All right. The next one the next point is what? At C. What's the value of x at C?
4.5.
X equals to 4.5 meter. Bending moment. Let's solve for bending moment. Now, bending moment. The difference between bending moment and shear force is that at each point for shear force, you calculate it twice, right? But for bending moment, you only calculate it once. Though for this shear force, is actually once also. But you see why we said we calculate it twice. If we check alkyl output, what you are going to see, let's say this question is in alkyl output. For this one, you are going to see this one at A, you are going to see this one at C, and you see this one at B. Are you with me? You will see this first value, and you will see this first value. It's still the same thing, but this is more explanatory. Are you getting me at all? So by the time, if you are going through your textbook, by the time you see this, you should know what it means. By the time you see this one, and you are not seeing this, you should know what it means. By the time you see just 0, and you are not seeing this one, you should know what it means. But you see the main reason why we need to have shear force value twice at each point. You see the main reason. Now, bending moment calculation. At A, x equals to 0 meter. Bending moment is equals to what? 0. No stress. Just because we said that bending moment must start with 0 and must what? End with 0. Now at C, when x is equals to 4.5 meter, what's bending moment value? Now, how do you calculate bending moment value at C? You simply take the moment of the forces behind that very point. You know, I'm on point C. Right, I'm on point C. Behind C, I'm having, what force am I having at behind C? I'm having RAY, meaning you take the moment of RAY to C. we take the moment of what RAY to C. Let's say I'm on point B. Behind B, how many forces am I having? Two. Meaning you take the moment of these two forces toward B. Can you now see what I said initially? If you don't know how to solve the support reaction when it comes to you taking your moment, it will be very, very difficult for you to get the value of bending moment, which is bending moment calculation. But now, I believe every one of us here, you understood how support reaction calculation works, right? Yeah. So with that, you shouldn't have any problem for this guy. You shouldn't have any problem for this guy. Now, bending moment at C. You already know what we are doing. We are taking the moment of this force to C, right? We are taking the moment of RAY to C. Now, let's take the moment of RAY to C. What's RAY? 16.5. 16.5 is covering what distance? 4.5. Okay, let's write that. I'm having 16.5 times 4.5. But the question is, what direction? Is it clockwise? Is it anti-clockwise? Clockwise. Go back to what you have, what you've drawn. Go back there. What do you have? Is it clockwise or anti-clockwise? Clockwise. Why is it clockwise? It is going in the direction of your work clock. That is the simplest way to understand it. It is whenever you have your arrow of your force going in the direction of your work clock, it is what? Clockwise. When it is going against it, it is what? Anti-clockwise. So this is clockwise just because I'm going in the direction of my what? Work clock. So by clockwise, positive or negative? Positive. So input this. What's your value? What do you call it? 74.25 kilonewton meter. Right? Now the next one at B, right? At B, without solving, what will be the value of bending moment? Bending moment must start with what? 0 and must end with what? 0. Without solving, bending moment is equal to 0. But let's see. Bending moment. Now the same idea. So meaning I'm taking the moment of these two guys. I'm taking the moment of A to B, and I'm taking the moment of the force at C to B. Now let's take the moment of the force at A first. All right, I want that will be what? 16.5 times what? Positive or negative? Positive. Why is it positive? I'm already seeing some people looking like, hope you are getting it. Because is it hard? Are you getting what we are doing here? Or you are lost? That's why I say that you must understand how to take your movement. That's the only thing that can convince you here. How to take your movement. And I believe if you what we've done previously, you should be able to understand what we are saying. So I said this 16.5 is going to be, it is going in this manner. Right? It is going like this. Going like this, meaning it is going in the direction of your work clock. It is going in the what? Direction of your work clock. Now, check what we have previously. You know, I have 1, 2, 3, 4. Right? Check that diagram. Is it 1? Is it 2? Is it 3? Is it 4? It is 1, right? And 1 is going in what direction? Clockwise, positive. So you have what? Meaning you have plus 16.5 times what? Times 10. You've considered this force, right? The next one is what? 30 kilonewton. 30. No, you don't say minus just because it is acting in this manner. Is it going clockwise or is it going anti-clockwise? It is. You are taking minus just because it is going anti-clockwise. You know, you are going to be. You're going to be meaning anti-clockwise. Right? Are we together? Yes. I'm going to be meaning anti-clockwise, but anti-clockwise negative. What if I'm going to A? Is it going to be negative? It will be what? Clockwise. So because the nature of this force is acting downward, it does not mean it will be negative. It doesn't mean it will be negative. That's why I said for every equation of equilibrium, they have what? Sign convention. So as far as movement is concerned, the sign convention is what? Either clockwise or anti-clockwise. Either clockwise or anti-clockwise. So irrespective of the nature of force, you must still consider if it is what? Clockwise or anti-clockwise. So I'm taking moments.
But for your shear force, you are dealing with the direction of the vertical.
Yeah, I'm dealing with the direction of the vertical force. Just because I'm using these two, I'm using this equation, summation of f of y equals to 0. Force of this nature positive, force of this nature negative. We said bending moment. Moment, this is moment, this is force. This is moment, this is force. Any question on that? No question. Don't worry. If you are too fast in class, you watch the video, you understand better. Or you can just call one of your friends to explain for you. You know, there's no time, for time's sake. Now, from here, 16.5 times 10, right? Alright. 16, one house, please. 16.5 times 10. That's for this force at point A, right? Now, the force at point C. The force at point C, that will be what? 30 times
5.5.
30 times 5.5. In what direction? Anti-clockwise. Meaning it is going in this manner. It is going in this manner, right? Anti-clockwise. By anti-clockwise, what do we have? Negative. Negative, open bracket, 30 times 5.5. And this will give you 0. This time, this is what? 165, which is equals to what? 0. 0. In some cases, let's say you have, decorum please. In some cases, let's say you by the time you finish solving and you're having negative 0.2 or 0.3, you can still approximate this as 0. Are you with me? You can still approximate it as 0, provided the value provided the value that you got can't be approximated to 1. Are you getting me? Any question on that? Let's say for instance, I'm having 0.5 or 0.7. It means something is wrong. Provided your value can't be exactly, provided your value can't be approximated to 1, you are correct. If it's irrespective of the sign, if it is positive, negative, as far as you can approximate it to 0, you are to 1, you are correct. You are correct. Can you now see that it is very, very easy to know if you are correct with what you are doing or not? Just because if these conditions are met. The first one, when it comes to shear force, is that shear force must end with 0. And what we've done so far, it's ended with 0, meaning I'm correct. The second one is that for bending moment calculation, the first one is that it must start with 0 and end with 0. And so far, by calculation, we've seen that we are correct, meaning no stress. Now, bending moment diagram. This value that we've calculated at each point, we are going to plot it on a graph sheet. We are going to plot it on a graph sheet. This value that we've calculated, we are going to plot it on a graph sheet. So that's what it means when we say shear force and bending moment diagram. Your shear force value and your bending moment value, you are plotting it on what? A graph sheet, right? So let's do that. Meaning, draw another diagram. Draw another diagram. Wow. Shear force and bending moment diagram. So far, we've calculated the support reaction. We've done the shear force and bending moment calculations, right? Now, the last thing we need to consider is the shear force and bending moment diagrams. Shear force and bending moment diagram. As I said you are plotting this diagram on your graph sheet, right? You are plotting this diagram on your graph sheet. So we are going to imagine this is a graph sheet, right? I believe you all have done that. So we imagine this is a graph sheet. I will have something of this. You notice that I'm drawing this. You notice that I'm drawing this straight line at each point, right? At each point on the beam, I'm drawing this straight line, right? Now from here, since we said we are drawing this diagram on a graph sheet, by graph sheet, you always have a reference line, meaning the origin, 0 for the y-axis and 0 for the x-axis. Now, the first diagram that we want to draw is the what? Shear force diagram. So let's take a reference line for our shear force diagram, meaning the origin 0, 0. So let's say this is my reference line for my shear force. This is what? 0. By graph, positive, negative, right? Positive, negative. So what we are doing here is that at each point, we are going to identify the forces, the value of forces at each point. Now, looking at this beam, what's the greatest value of forces? 30 kilonewton, right? 30, negative 30. This is 16.5, this is 14.5, and this is 30. Is it 13 or 14? 13.5. So this is the greatest value of forces, right? Now, if this is my origin, let's say I have 30 here. Let's say this is what? 30. Meaning 16.5 will be between this 0 to 30, right? Yeah. I believe you all are familiar with this. I'm just doing graph sheet here. So let's say this is, at this point, I'm having 16. At this point, I'm having what? 16.5 kilonewton. What do you observe? This line is for A. At A, I'm having RAY, which is equal to 16.5. And I've taken my reference point. This is 0, this is 30. If you are 0 to 30, 16.5 will be between this line, right? So I'm saying this is 16.5. If this is 16.5, do we have any value on A aside from 16.5? No. Now, all right, I said we are plotting shear force value. Go back to shear force calculation, please. Shear force calculation. At A, what's the value we have there at A? 16.5. This is 16.5. Now go to C. How many value of shear force do we have? 2. Meaning for this very line, which is for C, I'll be indicating what? 2 points. I'll be indicating what? 2 points. Now identify what's the first value here? 16.5. If this is 16.5 on A, at C, I'm also having that same point as what? 16.5, right? So let's say this is this point. I'm having it at 16.5 kilonewton. Check the next value. The next value is what? Minus what? 30. If the highest value here is 30, the highest value here is also what? 30. Mathematically, we know that. The highest value here is 30. This is the positive region. This is the negative region. So let's say I'm having the highest value. If this is my, let's say this is my greatest value, which is 30 kilonewton, right? Then 13.5 will be somewhere around here. Let's say somewhere around here. You know, this is not a graph sheet. I'm just imagining it being a graph sheet. So let's say this is 13. Let's bring it down here. 13.5 kilonewton. What do you observe? When I say 13.5, it is closer to my origin compared to 16.5, right? Which is that's how it's supposed to be, right? That's how it's meant to be. So always take note of that. You won't say that you have 16.5 here and you are doing 13.5 here. It's wrong. It's wrong. Graphically, it's wrong. You know, am I communicating? So what I'm saying is that if from year to year is 30, right? From year to year is 30, and you've indicated 16.5, you know, you are done with part A. Now, part C, I'm having two values, 16.5 and what? Negative 13.5. If this is, what do you say? Negative. If this is 16.5, I've indicated the first value, right? Now, the second value, which is 13.5, me putting 13.5 here, is it correct? No. It's not correct. Because if 16.5 is, the difference from 0 to 16.5 is in this manner, then this one should be closer to the origin. Are you getting me? So what I'm trying to say is that if you say this is 16.5 and you are putting 13.5 here, it means you are what? You are wrong. So if you submit this in your exam and when they release the results, you are seeing, probably you believe you get A and you are seeing B, you should know why you had B. Hope I'm communicating. Yes. Alright, now at C, aside from these two values, do I have any value again? No. Do I have any value again? No. Meaning I'm done with C. Now moving on to the next one. What's the first value? Minus 13.5. So meaning I have 13.5 kilonewton. The last one is what? Back to what? 0. Shear force must what? End with 0. Don't forget, I need shear force diagram. But what I've done here, I've only indicated the value of shear force that I've calculated so far. Now, how it works is that respectively, what did I say? Respectively. The way you assign or the way you indicated those points, respectively, join them together. Join them together. Now, let's do that. I have what? From here, 0 to the first one, right? 16.5.
Minus 13.5.
The next one, then I have this, then I have this. Where this is positive, this is what? Negative. Now, shade, indicate. Indicate. This is what? Positive. This is what? Negative. Right. Shear force diagram. Shear force diagram. So this is what you see in your textbook. This is what you see. Now, from here, okay, let's proceed. This is just my shear force diagram. The next one is what? Bending moment diagram. The way shear force diagram works, the way you plotted it, that's the way you're also plotting your bending moment diagram. But now, he asked a question earlier. He was like, okay, let's do this first before I answer that. Let's say from here, okay, let me use this place. Let's say from here, I have this, and I have this also. This is 30 kilonewton meter. This is also 30 kilonewton meter. What's the difference between this and this? The difference is that this one is upward, this one is downward.
Yes.
So in textbook, your bending moment, you always see it upward. Mind you, both of them are positive. You know, in this case, we indicated the signs. This being positive and this being what? Negative. So if you're having this, it's positive. If you're having this, it's still positive. The difference is that in textbooks, you commonly see this one. Textbook commonly use this one, meaning in many textbooks, this is what you see. But in some textbook, you will see this. But structurally, let's say you are doing structure as a civil engineering student, this is what you learn. That this is how you should always draw your bending moment diagram. And I've explained that. Let's say this is a slab. You know, this is in a layman term, we call it decking, right? But in civil engineering, as a civil engineering student, we call it what? Slab. Now, let's say this slab, God forbid, this slab wants to like collapse, right? This is not this slab. Okay. Let's say this slab. Let's say this slab. This slab. Give me another word instead of collapse. Okay. No, let this slab. I don't want to use collapse now. I want to use.
It's what's it called?
Okay. Let's say this slab wants to collapse. Let me use my local language, please. Let's say this slab wants to collapse. You know, in what nature, in what manner is it going to collapse? Is it downward or upward? Downward. By what has happened is due to the movement, right? Due to the movement. So when I say this structurally, can you see what I'm trying to say? Meaning structurally, this is my bending moment diagram. But in strength of material, for the electrical, the agri, the mechatronics, and other departments, we will see this in textbooks. Do you understand? But for we, the civil engineering students, structurally, this is what we are saying by bending moment. So meaning that in your exam, if you draw this, you are correct. But I will advise whatever your lecturer teaching in class, draw it for them. It's either they teach you this one or they draw you this, or they teach you this one.
I know that's what my lecturer will do.
As far as Lasso Tech is concerned, I will advise you to draw this one. Are you with me? But as far as other schools concerned, I will advise you to draw this one. But this what I'll be using for this video, I'll be taking this positive side. I'm not using this because in textbooks, it's rare you see this in textbooks. Since you are not doing structure, but this one in Gambari taught you. But you know the difference now. So go with engineer Gambari. Alright, now from here, let's draw bending moment diagram. At point A, what's the value of bending moment? Before that, don't forget, take your reference line. Very, very important. Take your reference line. This is what? 0.
You want to go upwards now.
I'm doing upward.
Going upwards.
My graph sheet is not enough. If not, I will have done it in the middle. But let me use this. Now, what's your question? No, now, bending moment. Shear force has a reference line. Bending moment has a reference line. This is the reference line for shear force. Now, the reference line for bending moment. Let's say this is bending moment. Any question? This is my reference line for. Do you have a question? Yeah, on that same graph. On that same graph. One else, please. Now, from here, this is the reference line for my bending moment, right? This is 0. At point A, what's the value of bending moment? 0. Meaning your first point. This is it, right?
Yes.
At point C, what's the value of bending moment? 4 points. 4 point what? 70 what? 70 something. 74.25. You know, this is the positive region, this is the negative region. My board is not enough to show my negative region. So let's say all my values, they are positive value. 70 what? 74.25. So let's say I have 74.25 at this point. At B, what's the value of bending moment? 0. Right? Meaning, respectively, draw your diagram. What do you have? You have this, right?
Yes.
Then you have this. Now, shade. What do you have? Positive. Right. Bending moment diagram. Bending moment diagram. It's count off. I said respectively. And even you use a graph and you use your lines, your numbers to scale. You have it in this manner.
If you use French curve,
It is still being
in the same manner. So the answer to that, is that if you have a simply supported beam loaded with a point load, this is your bending moment. Your bending moment is always in triangle form. But if you have your simply supported beam loaded with a UDL, your bending moment is going to be parabolic in nature. Right? Any questions so far? No question. So this is your bending moment. This is your shear force diagram and bending moment diagram. So meaning that a beam loaded with different types of load, right? A beam loaded with different types of load has their respective shear force and bending moment diagram. For this particular beam, this is the shear force diagram and this is the bending moment diagram. So what that means is that for every beam, let's say simply supported beam, in general, for a simply supported beam loaded with a point load, this will always be the shear force diagram and this will always be the what? Bending moment diagram. You know, for this one, it's just loaded with a single load. What if it is loaded with several loads? Let's say 2 loads. In this case, I'll still have it in the same pattern. Nothing is changing. It must follow this pattern, right? Now, let's see this. From here, I'm having 0 here, right?
Yes.
This 0, this support reaction, what's the value? 16.5, right? On getting to this point, I'm having a beam. I'm going in this manner. Just that your beam is still a straight line. I'm having a beam, meaning I have a straight line, right? On getting to this point, meaning point C, what's the load of the force? 30. Meaning it is coming downward. It is pressing it is pushing it down. 30. Are you getting me? You know, this is 16.5 kilonewton. On getting to C, I'm having 30 kilonewton. By 30 kilonewton, it means 30 kilonewton is going to push 16.5 kilonewton down. You'll be left with what? 13.5. Right? From this 13.5, I'm having a B, draw a straight line. On getting to this place, which is B, I'm having 30.5. Go back. Return to your lines. This is zero. It's balanced. Yeah, it is balanced. Can you see how when you just did here, you represented the word equilibrium graphically. You represented the word equilibrium graphically. So that's it. So that's you can see it's very interesting. Shear force and BMD diagram.
Is that the reason why we have two supports there to prevent the
Probably.
any moment that will eventually cause this
So all right, that's it.